Hi everyone, my name is Hamza Paracha and I'm a software engineering student at the University of Guelph. Today I want to explain one AWS service I find extremely powerful for modern AI applications. That is AWS Bedrock. This service was also one of the major highlights at last year's AWS reInvent, which is why I found it especially interesting to explore and build with. A common challenge developers face is something called model lock-in. When you build an AI application, you usually have to commit to one model provider and design your entire backend around it. That makes it difficult to adapt when newer or more efficient models become available. But on the other hand, Amazon Bedrock completely removes that friction. It provides a unified serverless API that gives you direct access to multiple foundation models, so you can select and switch models instantly without rewriting your application or managing any infrastructure. This makes your systems more adaptable, easier to scale, and more cost efficient right from the start. The most important idea behind Bedrock is model flexibility. Different models are designed for different tasks, and Bedrock allows us to use the right one for the job. For instance, Cohere models are optimized for semantic search and text retrieval. Anthropic's Claude models handle reasoning, coding, and structured analysis. Meta's Llama models provide fast responses for chat applications. And Nova by AWS models support multi-model tasks like understanding images and generating structured outputs. Since all of them are accessed through the exact same API, developers can test performance, accuracy, and cost trade-offs simply by swapping model IDs. This means you're no longer building around a single model, but you're building around the problem you want to solve. Once you choose a model, the next step is making it reliable. Foundation models are powerful, but they don't know your private data. That's where knowledge bases for Amazon Bedrocks come in. They allow you to connect the AI to real data sources like Amazon S3, SharePoint, or any custom internal database. Bedrock automatically indexes that data and retrieves the relevant information when a user asks a question. This is known as Retrieval Augmented Generation, or RAG, and it ensures your AI gives accurate, grounded answers instead of guessing. Now, let's move on from intelligence and memory to execution. On this slide, you can see heavy lifting involved in traditional AI setups. Developers usually have to provision servers, manage GPUs, and connect backend services manually. But with Amazon Bedrock, we don't have to do any of that. Because Bedrock is fully managed, AWS handles the infrastructure, scaling, and optimization. That allows us to focus purely on building intelligent applications. And this is where AWS Lambda comes in. Lambda gives our AI systems the ability to take real-life action. So instead of just generating text, the model can trigger serverless functions that actually interact with real APIs or databases. For example, a campus assistant powered by Bedrock could answer a student's question and use Lambda to actually retrieve their class timetable or reserve a study room in real time. This is the shift from generative AI to agentic AI, where system moves beyond conversation and starts performing useful tasks. To recap, Amazon Bedrock gives us three major capabilities. Number one, model choice through a unified API. Number two, reliable memory using knowledge bases and RAG. And the third, the ability to build intelligent agents that can take action through AWS Lambda. This makes it possible to build scalable and practical AI systems on AWS. As an AWS Club captain, my goal is to help students move beyond just learning AWS and start building real cloud and AI solutions. Thank you.